Alright, hi everyone. Today we're going to talk about how to solve inequalities in one variable, which means that the inequality is going to involve just one variable. And so what we're going to do is, in order to solve an inequality, the goal is to isolate the variable on one side. Alright, so we're going to solve the inequality, and then we're going to graph the solution, and then we're going to state the solution using what's new is what's called interval notation. Alright, so this is something that you'll need to know eventually. Alright, so first of all, to solve this inequality, it's actually very simple. You want to isolate the letter x. So we do what's opposite over here. We want to get rid of the -1, so we're going to start out by adding 1 to both sides. So we're going to go +1, like that. Okay, and as you can see, when you +1, what you have left here is you got 3x is bigger than 6. Alright, and so the goal is to get x by itself. Right, so the next step is to go ahead and divide both sides by 3 so that that 3 goes away and x is by itself. So 3x, okay, greater than 6, and then we're going to go ahead and divide both sides by 3. Alright, and notice that you see that x now is bigger than or bigger than 2. Right, so that's your solution. As long as you pick any x value that's bigger than 2, then this statement will be true. Alright? So what we're going to do is, this is our solution. Okay? Now we're going to go ahead and graph the solution. And so sometimes it's best to represent the solution graphically. So what we're going to do is we're going to go ahead and draw a number line. Looks like this. Okay? And then we're going to just label some points. So 0, 1, 2, 3, 4, and on. -1, -2, -3, -4, and on. Okay, so to graph the solution, what we're gonna do is, of course, whenever you see, from now on, whenever you see a greater than, whenever you see a less than or greater than, you're gonna graph it using open parentheses. Okay. Which is very similar to open circle, but instead of using a circle, from now on we're going to use parentheses. Alright, I'll show you what it means. So the solution is anything that's bigger than 2. So we're going to go to the number 2, and instead of drawing a circle, which is what you used to do, we're going to do a parentheses. Alright, and then we shade anything that's bigger than 2, so that will be shaded. Alright, as you can see. Alright, so parentheses, it means open. It's the same as an open circle. Alright, so we graph the solution. Anything that's bigger than 2 is going to be a solution. And then the last thing we'll do is we're going to write the solution using interval notation. So here's how you write using interval notation. So interval notation. Okay. Once you have the graphical representation of the solution, interval notation can be drawn from that graph, from where the solution is shaded. So if you look carefully, the solution starts after 2. It doesn't include 2, and then it goes all the way to infinity. And the way how we represent that is we go, okay, parentheses, okay, 2. That's where it starts after 2, okay. And then it goes all the way to infinity. Okay, and keep in mind that at infinity, it's always open. In other words, we always use a parentheses at infinity. All right. So there you go. What this means here is that the solution starts after 2, and it goes all the way to positive infinity. Notice that it did not include 2. All right. And now on the next problem, we'll go through cases where 2 is also a solution. We'll see how the interval notation differs in that type of problem. Alright, so there we go, we're done. Now let's go on to this problem. And so to make this problem a bit more interesting, I'm gonna go ahead and add an equal to in this inequality so that we can get a different perspective on how that changed when it's an equal to. Alright, so again, we're trying to isolate x. there's a lot of things to do in this problem, so we're going to go ahead and start out by distributing the 3 and then distributing the 5. So here we go. So 4x plus 6 minus 9x less than or equal to 10 minus 5x. Alright, combine like terms. That becomes negative 5x plus 6, because 4x minus 9x is negative 5x, less than 10 minus 5x. I like to do things one step at a time. Notice that if we had add 5x to both sides, right? Okay, you ended up with a statement that says 6 is less than or equal to 10. Alright, but there's no longer any variable, right? So 6 less than or equal to 10 is a true statement. So this is true. Okay. What this means is that for any value of x you choose, it's a solution. In other words, the solution doesn't depend on the statement being true or false does not depend on any x value. It doesn't matter what x value you choose, it's going to be true. And the way how we shade the solution is we need a number line first. So I'm going to go ahead and draw a number line. So here's the graphical representation of the solution. Okay, so 0, 1, 2, 3, negative 1, negative 2, negative 3, and so on and so forth. Okay. When it's a true statement, the solution doesn't depend on any inequality, which implies that any number you pick on a number line is a solution. And so the way how we indicate that is we just kind of shaded everything on the number line. All right. So that's how you represent that graphically. Now, interval notation. Recall what I said earlier. I said that it's open at infinity. Alright, so if you look carefully, the solution is from negative infinity to positive infinity, and the way how we represent that is we go negative infinity to positive infinity. Alright, let me take you through another problem so that you can kind of get the full perspective of how this works. Alright, so let me go ahead, and that was number 2. Let me go ahead and take this away. Okay, then do another problem here. Oops, pens are falling. Alright. Okay, so another good problem is perhaps number 12. Okay, so we'll call it number 3 here, which is 3t is bigger than or equal to 6t plus 12. Alright, so again, we want to solve for t, graph the solution, and then we'll also want to state the solution using interval notation. Alright, so isolate the variable. I'm going to go ahead and move 6t to the left. So in this case, we're going to go ahead and subtract 6t to both sides. Okay. Alright, so we get negative 3t is bigger than or equal to 12. Divide both sides by negative 3. Okay. Did you remember to flip the inequality? Okay, so when you divide, negative 3. Okay, flip the inequality, because whenever you multiply or divide, you must flip the inequality. Alright, so there you go. The solution is t is less than or equal to negative 4. So as long as you choose a value for t that is less than or equal to negative 4, and plug it back in here, then the statement is true. Alright, so let's graph the solution. Construct our number line down here. Okay. 0, 1, 2, 3, 4, 5. Okay. -1, -2, -3, -4. Maybe I should add -5 and -6. Alright, so anything that is less than or equal to -4. So whenever you have a less than or equal to, or greater than or equal to, it's closed. Okay, so whenever you have a less than or equal to, or a greater than or equal to, this means closed. Okay, and we're gonna graph anything that's closed with brackets. Alright, so let me show you how to graph this inequality. Now, t less than or equal to -4. So usually in the old days you would have a solid circle to include -4, but we're going to use bracket from now on, which also means -4 is included. Anything's less than or equal to -4, shade to the left. Okay, and there you go, and that's the solution, graphical representation of the solution. Now, interval notation. Okay, so what you do is your solution starts at -infinity because it goes that way. Okay, so it starts at -infinity, and if you recall, I said that at infinity or -infinity is always open. That's why I use parentheses. So -infinity, and then the solution goes up to -4. Okay, so you got -4, and it includes -4, or it's closed at -4. So, and if you recall, we use bracket for close. So there you go. That's the solution for this same inequality using interval notations, graphical representation. Alright, so if you need help, you can slow down the video a little bit and pause, and then look at these definitions closely so that you don't make mistakes. Alright, check me out in the next lesson where I'm going to show you on how to solve absolute values inequalities and combined inequalities, which follows this lesson.